Hi guys, it's me Major from Major's Math, and today we're not just going to be talking about maths, it's physics related. So there's something called half-life, which you guys should know. You see, in GCSE you might learn about half-life later on. I'm not sure because I don't really do a lot. I know some things, but half-life is not something I know the fullest of. And okay, so let's talk about half-life. However, this is a math channel, so don't worry. I did find an equation. 100%. I discovered it, but I'm not sure if other people did as well. There is another equation, but that is something different. Now, okay, half-life. So in GCSE, if you have a mass given, like let's say 1 kg, of course representation. Let's say a radioactive something, radioactive, whatever it could ever be. Let's say possibly uranium-235. Well, anything that goes with radioactive decay, yeah. I'm not sure which kind, but anything that goes radioactive decay. Maybe. Let's hope it's correct. Okay, let's say radioactive. Let's not just put the whole word. So radioactive. Let's make this R, okay? So eventually, after some time, okay, it'll be 500 grams. And after another time, it'll be 250 grams. Okay, now if we take half-life, we can calculate it. And this is a bit odd, but there is a time that is involved, and that time seems to be a constant. Yes, that is true. The time is a constant. Okay, and that time, which for some reason, whatever, what that time, okay, can be found out. Now, if you find the time once, you can do nice stuff. Now, you might already know this. If there's 1 kilogram of radioactive isotope, let's just imagine an isotope with a half-life of 100 seconds. Very nice, right? How much will there be after 200 seconds? Okay, let's do that. That's 2 half-lives. So, we just divide it twice. So, if there's 1 kg after 100 seconds, if there was 1 kg after 100 seconds, 250. Okay, now you can do some nice stuff. Okay, you can try this and that. But what if I said this? If there was 252 grams of, okay, a radioactive isotope with a half-life, with a half-life of, okay, let's imagine something, 126.5 seconds, yes. Okay, how much would there be after 265 seconds? I can't remember what I said, so let's try find out. Let's just make a new one. Let's make something up, like if there was a radioactive substance, a radioactive substance of 252 grams, okay, that had 250 grams. If we had a sample, and its half-life, if the time it took to halve was 126.5 seconds, how much would there be after, let's say, a new question, 332 seconds? Now, a normal GCSE student doesn't have to know this. Oh my goodness. Normal GCSE student doesn't have to know this. However, since you're a viewer of my channel, you seem, and if you have watched it, some things, you should know things. Yes, you should know things that normal GCSE students don't know. And let's say another one. Okay? Let me think about it. Now, yes, the initial mass is this. And did you know that at this time, what we basically did was we divided it, wait, no, this is supposed to be the one after. The initial mass by a power of 2. Yes, it was a power of 2. And it would be think about how many half-lives are in the time. In this case, for that half-life, it was 2. Wait, sorry. This is not the one. It was 200. Yep, it was 200, not 100. So the half-life is 100. And that you put that down here. Okay. So, if you put 100 here and 200 there, that simplifies to 2 to the power to ma. Okay, divide by 2. So if you divide by 2 and divide by 2 again, that's just equal to dividing by 4. Yeah, and that works out. Okay. Well, I put it here, and I'm not 100% sure, but I trust myself that this should work. I trust myself that this should work. And to check, let's see a half-life. So let me propose. Okay, so if the initial mass was 252 grams, then that no. This the left-hand side should not be the initial mass. It should okay. So if the initial mass was 252 grams, okay, my friends. Then, shouldn't have erased everything. We shouldn't try to erase everything. Okay? Anyway, if the initial mass was 252 grams, let's convert it to kilograms. Why not? Okay? Let's do that. Let's convert it to kilograms. 0.25 kilograms. Okay? This should be the numerator. Okay? 2 to the power, yes. I trust myself. May this be true. Let me propose this. Let me propose this as an answer. I'm not sure though, so let's try a half-life. Let's try a half-life calculator. Okay. So let me see. 252. Well, in terms of kilograms, of course. A nice thing is, if you think about it, if you put it in kilograms or grams, if you think about it, after some time it would half in kilograms and it would half in grams. If you convert them, and if you convert it to grams, if it was after 126.5 seconds, it would convert into half, and it would be even half. Now, if you convert the kilogram measurement to grams, it would be this. Wait, would it be the same? Yes. Yes. It would be the same. Okay, now the time would be. Oh my goodness, time is. No. 342. Let me calculate this. Okay. Ooh. Now let's go for the moment of truth. power. Don't think too much. The base, the power. Oh my goodness. You know how nice it would be if my formula is correct? That's so nice. Please. Yes! That's so nice. It works. Right. What the? And there you go. So there's your answer. Now, to convert it to kilograms. Wait, what? No, to convert it to grams, you could just multiply by 1,000. Yeah. Not by 100. That one was correct. So multiply it by 1,000. Multiply it by 1,000, and that would become, if you estimate it to 2 BP. Wait, what? Sorry, if you round it to 2 dP, 408. Yes, 408.64. Yeah. So rounded to BP, it would be 408.64 grams. Excuse me? What? Oh, no. 40.84. Sorry. 40.86 grams. 40.86 grams. Sorry. Yep, 40.86 grams. Okay. This is estimated to be. Okay. Wait, what? No. This is rounded to 2 to be. Alright. And let me see. Yep. 40 point. Remember this point. There's a dot. What the? No. Sorry about this. Alright. And think about that. How nice is that? Now, just before we go, let's try having some fun. Well, maybe not some fun, but if this is the case, then that means that T over H can be calculated as as A. There's this weird thing with complex numbers. There's a thing that I might be searching on about if let's see if logarithms can have multiple solutions, but a solution. Okay, not multiple. Yeah, let's try the real solutions, because that is if all of these are real numbers, okay, and they're not negative, so only positive. Okay, then let's try what happened. So T over H should equal, yeah. Let me think about it. It possibly, no, it will. A certain kind, yes. A specific kind of LG, which is basically another way of saying log 2. But don't put this in your exams. I mean, even in A-level exams, you just use log base 2. But you can use this as a shorthand. It's a bit like sine squared. Right, log 2. Okay? A specific type. True. Right. By the way, if they're real and not 0. Okay? Yes. What's this going on? Wow. So, I seem to have made a mistake here. Don't think too much about that. However, the LG of the ratio between M after and M initially. Now, this in and of itself is nice, but we could have gone another route, which is the log E route. You know, you're taking, yes, you can call it yeah, you can. Log base E is, let's call it the natural logarithm. Okay, not well. Don't think too much about what natural logarithm means, but still, let's take the natural logarithm. You could have gone that route, but let's do that another day. Okay, so log 2. Okay, so we can convert this into a difference. The difference between the log base 2 of the initial mass and the mass after was. Now, I'm not sure whether you could use that, but the other route is possible. Yes, it is. Because there's this other equation which is a bit different, but don't worry about that. Now, please don't forget to like and subscribe. Have a good day, and see you next time.